All right, let's talk about something huge, something that's basically one of the biggest security holes on the entire internet. Today we're diving into BGP hijacking.
But look, to really wrap our heads around this, let's kick things off with a crazy story. Picture this, it's 2008. You want to watch a video, you type in youtube.com, and you get nothing, just an error page. And it's not just you, it's pretty much everyone on Earth. So the big question is, how did one country, trying to censor a website for its own people, manage to accidentally take it down for the entire planet?
Okay, let's get right into it. Section 1. When YouTube vanished. This is the story that really blew the lid off a huge, hidden problem with how the internet actually works.
So, February 2008. For a couple of hours, YouTube, the biggest video site in the world, just disappeared. It was like it was wiped off the map. And the weirdest part? It wasn't a server crash. It wasn't some kind of hack on YouTube's end. Nope. The problem was way deeper, hidden in the basic plumbing of the internet itself.
So what actually went down? Well, it started pretty simply. The Pakistani government wanted to block YouTube inside its borders, so their telecom authority set up what's called a black hole route. Basically, anyone in Pakistan trying to get to YouTube would just get sent to a dead end. Simple enough, right? But here's where it all went wrong. That local block, that little internal instruction, somehow got announced to the entire global internet. And all the routers around the world, well, they just listened. They updated their maps and started sending a huge chunk of the world's YouTube traffic straight into that dead end in Pakistan. Whoops.
Now, you're probably thinking, how on earth is an error like that even possible? To get it, we need to peek under the hood at how the internet actually navigates itself. Let's call it the internet's GPS.
Okay, first thing you have to realize is that the internet isn't just one big thing. It's not a single network. It's actually thousands of smaller independent networks all connected together. Think about big ISPs like Verizon or AT&T or Sprint. Each one of those is its own little kingdom, technically called an autonomous system or an AS. And there are thousands of these ASs all over the world.
So if the internet is all these separate networks, how do they all talk to each other? How does your request for a website get from your network to a server's network on the other side of the planet? Well, that's where something called the Border Gateway Protocol, or BGP, comes in. It is, and this is the best analogy, it's the GPS of the internet, or maybe its postal system. It's the set of rules these networks use to shout directions at each other, constantly updating the best way to get from point A to point B. So, let's put it all together. The internet is just a giant web of these autonomous systems, these ASs, and BGP is the language they use to coordinate everything. Without it, your laptop would have absolutely no idea how to find that cat video hosted on a server in another country. It would be total chaos.
And right there, in that system of coordination, lies the massive, gaping security hole. This brings us to the real heart of the issue. This whole thing is basically a system built on trust.
Yeah, you heard that right. Trust. You see, BGP was invented way back in the early days of the internet, when everyone kind of knew each other. So by default, it's designed to just trust whatever another network tells it. If one network announces a new, faster route to somewhere, all the other networks just go, okay, cool, and update their maps. There's no built-in fact-checking.
And this is where the trouble starts. So normally, YouTube's own network is out there announcing, hey, I'm YouTube, all YouTube traffic comes to me. Pretty simple. But with a hijack, some other random network can just pop up and shout, hold on everybody, I have a better, more specific route to YouTube, send all that traffic my way instead. And because of that trust-based system, everyone else just goes, oh, okay, sounds good, and redirects the traffic.
And that is exactly what brought YouTube down. The telecom in Pakistan announced a more specific path to YouTube's digital address. And in the world of BGP, more specific is always better. It's like having a GPS that says go to 123 Main Street versus one that just says go to Main Street. You're going to trust the more specific one. So routers all over the world updated their maps to this fake route. And in this case, the traffic just hit a dead end, a black hole. But think about it. A bad actor could do way more than that. They could be secretly reading your data or sending you to a fake website.
So that whole YouTube thing was a huge accidental wake-up call for a lot of people. But it was definitely not a one-time fluke. This has happened again and again and again. Which brings us to a quick look at the history of these hijacks.
Yeah, I mean, just look at this list. After the YouTube incident in 2008, you've got a Russian telecom in 2017 hijacking traffic meant for MasterCard and Visa.
Then, in 2018, a hijack was used to steal crypto from people using Amazon services. In 2019, a simple mistake in Switzerland sent a ton of European mobile data on a detour through China Telecom. And then again, in 2022, another crypto platform got hit.
And that 2022 attack, we're talking about a real price tag here. The attackers hijacked the service's digital address, which let them push out malicious code and steal almost $2 million. So this isn't some abstract technical problem anymore. We're talking about real money, stolen from real people.
Okay, so if the system is this broken, if it's based on this old-fashioned idea of trust, what's the fix? Is anyone doing anything about it? Well, that brings us to our last section, securing the internet's map. The big solution on the table is a system called Resource Public Key Infrastructure, or RPKI. It's kind of like adding a certified tamper-proof digital signature to those BGP directions. It uses modern cryptography to let a network prove without a doubt, yes, I am the real owner of this slice of the internet, and I am authorized to give you directions to it. It's basically a way to stop trusting and start verifying.
Sounds great, right? Problem solved? Well, not so fast. And this is the real kicker. The solution exists, but getting it implemented across the entire internet is a massive, massive undertaking. You need thousands of those independent networks all around the globe to get on board and set it up. And until that happens, and we're not there yet, the internet's GPS is still running on that old, vulnerable, trust-based system.
And that really leaves us with a pretty unsettling thought, doesn't it? Our entire modern world, our banks, our communication, our critical infrastructure, it all runs on an internet that depends on this incredibly fragile system of digital handshakes. It's the map that connects everything we do. Which begs the question, who's actually guarding it?